all in high school. In Georgia.
Oh, what's going on? What's going on? What's going on?
Raphael broke his baby. The ladies in the office next to me, two of them, and like one of them was freaking out today. So I went in and I was like, all right, who pinched the kid? They were all laughing. Yeah.
My son fell off the couch today face first, and then his feet came up over top of him, and he like bent his neck backwards, and it was so sad. And then he didn't want to cuddle with me while he was sad, and he just went straight to his crib and wanted to get in bed.
How old is he?
15 months.
Aww.
He was pretty sad, but he was happy when he got in his crib.
You're like, but why didn't you want me to make you feel better?
No, it made me sad.
I know. Braylon is like super fierce and independent, but like when she gets hurt, it like, not that I want her to get hurt, but I love that she still like comes to like to hug it out.
Yeah, Declan doesn't. When he gets hurt, he's tough and he doesn't want mom's hugs and kisses. He just wants to go comfort himself and cry it out.
With me and Braylon, if like other little kids are around, she's like, "I'm cool, mom. There's no blood. I'll just brush it off." Like, okay.
Ezra just tired right now.
What died?
See what?
Nothing. Okay, let's go. I don't know what any answers are, but I'll learn from you guys. I don't know why it wouldn't work.
What requirements must be checked when conducting a hypothesis test? Comparing two means with independence of that.
It's A and B, right?
I was going to say, I knew A for sure.
Sure. Makes sense. It does make sense. I really wish I knew what was going on, guys.
I feel like we've all had a really rough week.
Yeah.
Sorry.
You should have seen me in my last night's meeting because I have a cold, and yesterday was the worst day, and my brain was not working, and my nose was all... Anyway.
Yes.
So, for the third one, A and B?
Yes.
Yeah.
Number 4,
Yeah, I agree.
The test statistic for a hypothesis test comparing two means with independent samples is a...
T-score.
T-score.
Sorry.
Did you say Z-score?
T?
Oh, I was like...
T, like in Tommy.
Okay. I thought you said Z-score, and I was like, hold on. I'm confused now.
No, I said.
All right, number 5, 2 samples are independent if, I think it's B, knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yeah, it was very emphasized.
I remember that part, so I agree with that. I remember that part from the first 3 paragraphs of my reading.
It was like 3 times there. And then it said, some students think that it's this, but no, it's if it tells you nothing about it.
Okay, so...
For the next 6 questions, use the data file dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and the dentist office in Rexburg. Let mean population 1 be the mean bill at the Idaho Falls office, and let mean population mean 2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis. Alternative hypothesis? Is that alternative? There is a typo there. Null hypothesis. Population mean 1 equals population mean 2. An alternative hypothesis, population mean 1 is less than population mean 2. Use the level of significance alpha 0.1.
What is the degrees of freedom? I can't open that unless one of you wants to send it via email.
I can. Give me 1 second.
I'm going to try to open BYU again. Oh, now it's worse.
Amber, what did you do to your computer?
I don't know. It will take me to the BYU website, and then I push sign in, and then it's just error.
Nothing.
Add URL.
We're out of this mess.
And now I can't even see the BYUI home screen, so whatever. I promise I'm not texting. I have my quiz here.
She's cheating for us.
So I got 37.996.
I got that too.
And
same.
Amber, that email just came through.
Okay, thanks.
Anyways, my internet seems to it's doing like the circle thing, you know, so hopefully it is.
Yeah, I got it.
So next question, sample standard deviation for Rexburg. I got 206.637.
6.637.
206.
Oh, 206.
You get the same?
37.
I got the same. Just kidding.
Adriana got the same too?
Yeah.
And the test statistic.
Sorry, my screen is frozen again. So I can see, or I can hear you all, but I can't see you, and I can't do anything on my browser.
Oh, I know. I got for the 8, the test statistic, negative 0.434. Oh.
0.434. I'm dyslexic, guys. Totally.
This one is pretty easy. What do you think, Jeremy? This
So
topic?
far, yeah.
That's good. I'll study it tomorrow, I guess. More
There's
when
always a question.
Sorry.
that I'm not
Hold
ready
on.
for.
My internet froze. So on 7,
still
what did
with
you guys
us?
do? I know, it like wouldn't let me do anything.
7 is 206.637.
Okay. And number 8, negative
Negative 0.
0.034.
Yeah.
I'm good.
the p-value.
I got 0.333.
The p-value?
Yeah.
Huh. I got 0.667. Oh, my bad. My bad. I know what's wrong.
Do we have? Did I not? So the type of test, is that supposed to be less than, or is it
Yeah.
greater,
that's
greater than? Threw me off because, so if it's the mean is less than, if it's number 1 is less than, do we go less than or do we go greater than? In this one, they have value 1 being less than value 2.
Yeah. Well,
I see the word.
Go ahead.
I see the words less than. That's the only reason I put that on there.
Yeah, and that was correct. I think that's correct.
Okay.
The null hypothesis is population mean 1 equals population mean 2, and that's what appears in the 2 sample t-test. It says null hypothesis variable 1, population mean 1 equals population mean 2. So if we put less than, then it should be good.
Okay. And since the p-value is greater than, we failed to reject.
Question 11. Suppose instead that you use the alternative hypothesis, mu1 is not equal to mu2. What is the correct decision based on this evidence?
B.
I agree.
I think it's B.
So the p.
What's the p-value if you do that?
So the p-value is still greater.
Okay.
And we failed to reject the null hypothesis, right?
Yeah, so we have insufficient evidence that the mean dentist bills between the 2 cities are different.
I agree.
Yeah.
And this time I for reals agree. I'm not just saying that.
So for the next 6 questions, use the data file. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let mean 1 represent the mean number of times a month that a student from Colorado cooks dinner. Let mean 2 represent this mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis has a level of significance of 0.05. What is the appropriate alternative hypothesis?
Oh.
Different then.
So
So it would be B, not equal to?
yeah, not equal to.
Not equal to or different?
Not equal to, because it doesn't say that we think 1 is less than or greater than, just that we think the number is different.
Oh, so different.
Right.
Thank you, Raphael.
Just stuff like at random for whatever reason.
Sorry.
Good. What is the test?
What is the test statistic?
How do you guys say that so fast? I can't get it all in. Test statistic. Say it 5 times fast.
I don't. Then you'll end up saying testicles, and that's not appropriate
Yeah, you
for
just.
recordings.
I was going to say, even though we just said it while we're recording.
That's part of the joke.
You are so
Jeremy
funny.
tells jokes?
I have 0.845.
Me too.
Same.
So
You guys are just entering the numbers on the Excel into the other Excel, right?
No, we're calculating our.
Oh, stop.
Oh, I forgot to send you the new Excel.
okay.
Would you like the new Excel, Amber?
I didn't save the formula one, so I'm trying to find it, but I'm not doing a very good job. So
I meant, do you want the one from the quiz right now? The freshman
okay. It's not really helpful if I don't have the formula
Okay.
one. I'm trying to
just
find
checking.
one, but I know what you guys are doing, so at least that's good, right?
Yeah.
Okay,
Formulas. I mean, might
for
be
the 14, I got 0.411.
Yeah.
What decision do you make?
different.
0.411.
We failed to reject.
So we have to fail to reject, right?
Yeah.
Determine a 95% confidence interval for mu1 minus mu2. An estimate for the difference between mu1 and mu2. Input your answers below. Determine the margin of error for this 95% confidence interval.
Oh man, I have the hardest time with these ones. So how do we determine the margin of error again?
Does it not say on the forms Excel? I mean the formula Excel?
No.
Oh.
So there's a standard error of the mean, but there's no margin of error.
Gotcha. Well, margin of error is z or t times standard deviation divided by the square root of n. So if we have those,
Come here.
you're given all that information on the form or the Excel, right?
So would that be the 0.845 times the thing is there's no difference between the two.
Difference? What do you mean no difference?
Well, in the paired sample t-test, you take that difference. I still don't know how to do this part of it. For 17, the lower bound, and 18, do we just go off of the confidence interval that they give us? That the formula gives us?
The 95%?
Yeah.
Yeah. What are those? What's the lower and upper bound?
So it says the lower one, I have negative 2.214.
No.
In the upper one, it says 5.147.
Okay, so one more question.
I just...
He was waiting.
We're just stuck on number 16.
I don't know how to do number 16.
Let me find that thingy. Oh, there it is.
I like when we have these challenging questions.
You do like it?
I do.
Okay. Okay, now do you want to send me that Excel, someone, so that I can that too?
Got it.
Perfect.
I hope you like the title of this email.
Do I like the title of it?
I said I hope you do.
Antonio.
Fresh dinner is pretty great. Oh, look, there's Jeremy and Jeremiah. I think your evil twin is here.
Well,
Yeah, I realized I have a Gmail account for this, and I have a Gmail account for I work for a school district, and for some reason I was signed in on my work email.
Gotcha. So your evil twin is Jeremiah.
That's the official name. Did I miss anything?
Just us thinking.
So we solved this on Tuesday. This is one of the hard ones. Well, Raphael solved it.
What did you do last time?
wait, what?
What did you do last time to solve it?
I wish I wrote it down.
I tried several different times, and because I have the formula, I thought it was right. Margin of error. He had asterisk next to it. Over the square root of the sample size. But I don't know how to apply it to this kind of problem. This is the only one I got wrong on that last homework quiz, and it was like the first one. I always get the first one wrong. My bad luck.
And maybe them. Maybe yes. Maybe you. It's coming. I wonder. This is interesting.
What's interesting?
None of it.
What is our...
This is really not interesting. Okay. Can we go to the one sample test for this thing? No.
No. So what is our point estimate here?
Why is there a point estimate?
Which one?
So we need the appropriate Z value. For 95% confidence, it's 1.96.
What?
No one.
So we got the appropriate Z value is 1.96.
No one. One's coming. No one. Oh, maybe.
I have an answer of 2.001, no, 2. But I'm pretty sure it's not right.
Wait,
How do you
what?
get it?
It could be.
Well, I did the paired sample t-test in the Excel, and then I just took the differences, standard deviation, and t and n, and figured out the margin of error from that.
Oh, so you copied the Idaho Falls and Rickenburg values into.
Yes, I did. Well, Utah and Colorado.
And that gives you the differences on the one side.
Yeah. When you use the paired sample one. I don't know if it's right, but I did the margin of error. What?
Is the type of test that your type of test, is that not equal to?
That's what I put it as. That's what we were going with, right?
Okay. And then what?
And I did t times the standard deviation divided by square root of n.
Oh, so you use the t-score?
Yeah, I did use the t-score.
So that's 1.225 times
5.164. I'm about 2% positive it's right. Or less than 2%, maybe 0.9995%.
Are you adding statistics to our math problem?
I am.
All right, 5.16.
So did you find it?
So you got 2.000.
Yep, 2.0004. But 2. That's my answer. Anybody have a better one?
How did we get this 2 days ago?
I don't remember.
I want to say Raphael took that differences and he pasted it into the one sample t-test and then did something.
Maybe we can watch the recording.
Hey! Really good idea.
Well, the only
Is there a
thing
recording
that
about this?
I see here is that I'm not sure. So look, the margin of error should be t times sample deviation, sample standard deviation over square root of n. But we have two variables. How do you calculate that?
We have 2 variables.
Yeah.
So what Amber did was she put it into the paired sample t-test and got a differences column and used that differences, the values.
Who knows if that worked? Here, I'll take the blow since I didn't study it all, and I'll see if it's right.
Oh, you don't have to do that. So video number 2 is confidence intervals and checking requirements.
What is this standard error of the mean? Oh.
I may have typed it in wrong, but 13 is wrong. And then also 17 and 18 were wrong as well.
Dang it.
And the answer is not 2. What did you guys put for number 13?
We put 0.845.
That's wrong.
That's what they gave. That's the. Which one is that?
What is the test statistic?
Huh. Am I missing a value? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh. Does it change if we change the type of test?
I guess the problem is that we put them backwards.
Huh?
I think the problem is we put them backwards. When we enter them.
I was under the impression that we had to put Idaho Falls first.
Oh, I guess that is. Oh.
Wait, is it Idaho Falls or no? First is Colorado.
Huh?
Colorado's first.
Oh, Colorado. I mean, yeah, I switched them. So Colorado. So Colorado's supposed to be first and then Utah?
Yeah. So that's why we got it just backwards. So it's
I put
it's
mine.
not 0.845, it's negative. Minus 8.845.
Oh, so it's just negative. But it's the same.
The p-value is the same, that's why we got it right.
Gotcha.
So
Well, shoot.
the bounds are different, are the same values, but backwards.
So we're supposed to negative 13 needs to be negative.
Negative
The
5.
thing is,
Oh, yeah.
they talked about in the lesson how sometimes that doesn't matter.
Apparently it did this time.
All that really changes is the way that you would state it.
Did the lower and upper bound change though? Because we got those wrong too.
So the lower would now be negative 5.147.
And the upper
would be a positive 2.214.
Oh, it just switched. I see.
Yeah, but like in the lesson, it said it didn't really matter because all that you would switch is the way that you word the question,
I see.
or the way that you would word your solution or your findings. So 13 is negative 17, 18. Were those the only three?
Yes. So we're just still stuck on 16, and it's not 2. But you could do the same thing now that you have the right numbers. Not that they changed, but yeah, I don't know how to do it. Sorry, guys.
So video number 2 in lesson 13 has a margin of error thing. So it's saying 100% confidence level interval formula T times the standard deviation divided by the square root of the sample. Oh my gosh.
All of the answers are B in this quiz, just in case anyone's wondering.
How do you get that? How do you get that number?
Does the sample mean 1 minus sample mean 2 have anything to do with it? What does that mean?
So the margin of error, according to the video, maybe I can share this on the screen.
Oh, there it is. It's t
There it is.
times square root of. Did you find that?
T times the square root of... Don't just stop. Keep going.
Right there. Equals t times parentheses square root of parentheses. Standard deviation of variable 1 squared.
I've got. But is the t-score for this, would it be that negative 0.845?
Yeah, that's the t-score.
Why would they throw that 95% in there if they're just... Is that just to throw us off? So that's...
Probably.
Huh. Okay, so... Eight, 4, 5. Square. So in this case, S1 is Colorado.
Yeah.
And S1 is standard deviation, right? The first one? Oh, but we have to square it first. I don't remember this formula in the reading. N1, which is 10 plus.
Maybe you want to try -2 just for kicks and giggles?
12. Okay.
Take that. No.
Okay. Here we go. 4.517. Divided by 10.
Oh my word, excuse me.
2 point.
That happens like randomly. I'll get like one hiccup, just like out of nowhere, one hiccup.
That's how my husband is. Lucky.
Like I get because I get the hiccups every day. So like in the middle of the day, I'll get the hiccups, and then like once at night, I'll just get like this one random hiccup. When I was pregnant, my daughter and I would trade them. Like I literally had hiccups like half of my pregnancy. It was ridiculous.
It's funny. I did never have hiccups, which is odd for me. So it was noticeable. Declan definitely had the hiccups, but I never did.
Yeah, I would get them, and then I would stop, and then she would get them, and then she would stop, and then I'd get them back. And this would go on like all day long.
Magnesium helps with hiccups, and so do bananas, which makes sense because, I mean,
Magnesium. They always happen when I was at work.
I don't know.
There wasn't much I could do.
Okay, I got, but it's a negative number.
That's okay, isn't it? Is that not okay?
I got negative 1.467.
How did you do that?
So there's this margin of error formula from a video in this lesson.
What is
Why is
it?
my mouse cursor disappearing? It'd be easier if I could show it to you.
You were showing us your screen.
I don't think it was the right screen. I gotta get rid of some things here, make it easier to tell what's going on. You anymore?
Okay, so
Raphael, I love how you say something and then
No. He does it all the time.
it's not good for nerves.
Jeremy, I got the margin of error negative 3.681.
What?
Negative
What'd you get?
3.681.
I can't hear. Negative.
3.681.
Negative 8.681.
How did you
Negative
get that?
3681.
Yeah, it keeps breaking up. I don't know. Maybe it's my microphone or my headphones.
3,
Negative 3,
6,
6, 8.
8,
That's
1.
Is there a
what I
decimal
got.
in there?
Yes.
3.681.
Yes.
Yep.
That's what I got.
All
But
right, how'd you get that?
So I also got negative 1.467 as the point estimate. That is the mean.
See, I got that as the margin of error.
I submitted it. He's right.
Negative 0.68.
No, positive.
Wait, what?
I thought he said positive, so I put positive 3.681.
Oh.
Oh,
Didn't he say
It's a
positive?
No.
Well, I didn't put the negative, so it's 3.681.
All right.
I didn't hit
that
the
makes
negative part.
sense.
So how did we come by that?
I trusted Raphael like I did on Monday. I feel like we need to go back and watch our group meeting from Monday.
Right. You're doing wrong.
So it's a pot.
Sorry.
So Raphael, what'd you do?
That's a good question. So that's the thing. You see that in the video says that the confidence interval formula is sample mean 1 minus sample mean 2.
Yeah.
Yeah.
So that's the point estimate.
So it did have to do with that above the question.
So that's 15.2 minus 16.667.
Yeah.
And that is
Negative
so how does
1.467.
and how does that fit in?
That is the middle point of the confidence interval. If you want to know the margin of error, when we're talking of the margin of error is how much above and how much below the point estimate. And I feel like I understand. I remember now that I was explaining this last time. I just didn't remember.
So we got the mean number 1 minus mean number 2, and then how does that give us the margin of error?
You just have to subtract and add to the point estimate. And the way you do it is you get negative 5.147.
So I'm still lost because, okay, negative 5.147 and
That's the lower bound.
Okay, so add the margin of error to that.
You want to subtract it.
Guys are making any sense. I lost you at the point of error. Or the
Yeah.
Subtract it. If you subtract it, then you're gonna add it because there's two negative. There's two minus.
But the answer is positive, right?
Yeah, that's what I don't know why. You know what I mean?
I don't.
I'm still at negative 1.467. What'd you do after that?
Yeah.
I don't know. It's just like
It just happened magically.
Well, he got the wrong answer. Adriana didn't hear him right and got the right answer.
At least you got the right number. I mean, what are the chances of
So
that?
unless we can miscommunicate on the test, I don't know how I'm going to get this.
So Raphael, how did you do it?
Are you sure
Oh,
the answer? 'Cause
I missed one.
I turned it in. It said correct.
that was
So
right.
it said, oh, I mistyped 15.
I think I mistyped 8.
I mistyped one of the numbers too, so I got
selected the
18
wrong
out of 18.
So look, guys. Let me see this.
Just write down what you did and then show me. Or explain. Go ahead. Explain.
Just think of it like this. Let me see. Can I screen share? Can you see this? Can you see my screen?
Yeah, like mirror.
Isn't it cool? Okay, so look. Here's the video, the second video, as Jeremy was saying, and I just stopped it right where you got the formula for the confidence interval.
Yeah, that was the one I was trying. I was trying the one at the bottom because I thought that's all we were looking for.
Yeah, and I was trying that too, but when I saw this, I got it because we want to find the point estimate. Again, the point estimate is how much is the middle point. Like, how to explain it? Okay,
I know
if
that.
outcomes is the higher bound, and navigation is the lower bound. The point estimate should be in between, right in between. So 1, 2, 3, 4, 5. This will be the one. It will be here, right? So I just have to add to the point estimate. I just have to add whatever adds to the higher bound and subtract whatever subtracts to the lower bound, and that's how I get the confidence interval. That's why here says plus or minus the margin of error. Are you following me, or is that?
A little bit more, yes.
So when I go here, what I do is, oh, I found it. So the margin of the point estimate is variable 1, mean of the variable 1, minus mean of the variable 2. Here it is, 1.467. That is the point in between these two numbers.
Yeah.
This is that you have to add and subtract. And in this case, you want to subtract this from this.
So
Okay.
so how do you know to nail down that one particular one out of both those numbers?
Just like this.
Maybe it needs to be, maybe it can't be negative.
See? Do you see it?
It's positive right there.
Yep.
So this minus this is the difference, or what is in between.
Okay.
Now, to add to this one, so equals this plus, oh, never mind.
Yeah, you subtract from a negative, you're going to get an even smaller negative number.
That's true. I need to add it, that's why. Okay, well, grant for this one, because I don't know, but then this is the safety check, and then this is equals this plus this.
I see. Okay, so you took the
Equals
mean
this.
of variable 1 minus the mean of variable 2, and then you got negative 1.46, and then you took that number and subtracted it from both confidence intervals. Right? Or added, subtracted, got it.
But you still get, my issue is you still get
No.
What?
I don't know. That's
What are we
what I-
saying no about? I was like, I understood it this time.
No, look. So it's kind of like, it doesn't make sense, but at the same time it does. I don't know.
Yeah.
I'm going to leave this here because that's going to be useful.
Maybe either negative or positive was right.
Maybe.
Let's test that.
All I was saying is,
Stop it.
can I stop the sharing? Good.
So I go, the door's locked.
Sorry, can I double check something? Number 13, is that a negative
You just
Okay.
leave and the door's
point
locked.
Okay. Guys, I have to go.
Okay.
When he ends it, it's going to end this, by the way.
Okay. Well, thanks for helping with that problem.
Yeah, I'm sorry. That was confusing. Confusing for me. I thought I
think I
understood
got
but
it.
then it was.
And it kind of makes
I'll
sense.
go watch our video from Monday.
Yeah. Thanks for being
Yeah.
patient
Bye.
with my
All right.
knowledge. See ya.